Hi, I'm Dick Seitz. Welcome to the Understanding Software Dynamics video series. Today's topic, what is KUtrace? KUtrace is a software tracing system to observe where all the time goes in complex software. So you can use it to understand long-tail, slow response times in transaction systems. It has overhead of less than 1%, so it's really suitable for data centers during the busiest hour of the day, for vehicles, control, or whatever. KUtrace records every transition between kernel and user mode execution on every core of a computer system, every system call, system return, interrupt return, every fault, every context switch. And then post-processing takes this very tiny trace and turns it into dynamic HTML pictures of every nanosecond of execution. Here's how it's designed. Over here on the left, there's user code running, lots of arbitrary programs. As they do system calls, interrupts, etc., they go through a small number of patches in the Linux kernel, which record through a loadable module trace entries for each event into a trace buffer, and then that buffer is later post-processed into pictures that you can look at. So the raw binary trace goes to a JSON file, which you can also write grep or awk scripts to look for interesting combinations, and an HTML file. Here's how an example of the events. Each green triangle is a recorded event. So here's a system call, system return, another system call, returns much later. Just 5 events here, 7 there over the course of about 100 microseconds on 4 different CPU cores, 0 through 3. The post-processing turns that into much more usable. We had a glitch. Much more usable picture of CPU 0 in idle, coming out of idle, running the scheduler code, finishing a system call, going back to the SSH daemon user code. Over here on CPU 1, nothing is happening, just idle. On CPU 2, there's a piece of hello world running and various system calls, and these pink things are page faults. In the middle of the write system call here, that write wakes up a kernel worker, and the arrows, and that kernel worker wakes up the SSH daemon. So the arcs show you what the cause and effect is. When you turn a display like that into something for an entire process, you get a full picture across all the CPUs of where all the time went. This is an example of running hello world remotely. So it starts over here on the left with an Ethernet interrupt to the SSH daemon code, which wakes up kernel worker code, which wakes up bash, which clones itself to make a second copy of bash, which loads and then transfers control to hello world, which takes a bunch of page faults, which eventually runs hello world, which does a write, which then goes back to the SSH daemon, which does a second write out over the network to give the response. And this whole 2.5 milliseconds of response time, you can see exactly where every nanosecond went through the critical path to get to the point where you have a result sent. That's the whole idea. Now this is sorted by CPU number 0 through 3. You can also sort by process ID number. And in the process display, you get to see here's the SSH daemon process. It's running and then waiting, running and then waiting. The first bash process, the second bash process is down here, kernel workers here. For each process on the process display, when it's not executing, the post-processing shows what it's waiting for. So in this case, the SSH daemon is waiting for a byte to come across a pipe from the kernel worker thread, which wakes it up and then it runs. Over here, the second bash copy is waiting right here to get a CPU. It's been created and woken up, but there's several microseconds here of waiting to get a CPU signed and getting the scheduler to start running the process. Where can you get the code? It's on github.com/digsite/KUtrace. There's Linux patches, free BSD patches, there's man pages, there's all the post-processing code. For the companion book, Understanding Software Dynamics, there's all the programs that are in the book and HTML files for the figures in the book that come from KUtrace that you can click on a button for a particular figure number and get right there, and then you can pan and zoom around from there. There's a companion video that talks through the Hello World trace dynamically. You can watch that next if you're interested. Here's a little unexpected kudos. When I gave a talk on this in March of 2022, I didn't realize that Don Knuth was listening. And at the end, he asked a few questions, and then he held up proceedings of a conference, and he said, 33 years ago, I issued this challenge of make a thorough analysis of everything your computer does during 1 second of computation. And then he said, KUtrace meets that 1 second challenge. There's no other software in the world that can do that right now. So in summary, KUtrace's software tracing system uses Linux kernel patches that records transitions between kernel mode and user mode execution. It has tiny overhead, so you can use it in production, busiest hour of the day data centers or driving Tesla autopilot or whatever. Post-processing turns the raw traces into dynamic HTML. Thanks a lot for listening. This is part of the Understanding Software Dynamics video series. Here's the book in case you're interested in a lot more detail. Thank you.